solving equations, we want to get the x on one side, all the numbers on the other, and then we finish with the division or multiplication step. So in this case, we're adding 15 to both sides. I'm getting 4x equals a 34. And then we're dividing both sides by 4. X equals 34 over 4. Please reduce where you can. I want this answer to be x equals 17 over 2. And we can always plug that x back in, whether we do it pen and paper, pencil and paper, or on a calculator. But 4 times 17 over 2 is 34 minus 15 equals 19. You can check any of these problems. Going across, we have negative 12x plus 20. We've got to be aware of signs. That negative 4 is what's being distributed. So we're going to subtract 20 on both sides, and I'm left with negative 12x equals 2. When I divide by negative 12, my x equals a negative 1/6. I'm going to reduce, and I'm going to move that negative in front of my fraction. Okay? We don't leave negative signs in the denominator. Here we need to distribute first. Alright, so when we distribute here, the 3 goes to both terms. 6x plus 12 plus 4x equals 22. Now I'm left with 10x plus 12 equals 22. We subtract 12 on both sides, we get 10, and my x equals a 1. Here, I'm going to subtract 3x on both sides. I'm going to add 8 on both sides, and we're left with 2x equals 24, and in this case, my x equals 12. On these problems, we're distributing first. So the 4 goes to both terms here, and the 5 goes to both terms here. You can do the distribution in one step. 12x plus 8 plus 5 equals 10x plus 5 minus 4x. I'm going to combine my like terms next. 12x plus 13 equals 10x and 4x is 6x plus 5. I'm going to subtract 6x on both sides because I like to keep my x positive. I'm going to subtract 13 on both sides. So we're left with 6x equals a negative 8. And when I divide by 6, my x equals a negative 4/3. I reduce, and the negative is either in front of the fraction or in front of the numerator. When you have a fraction, I'm a big fan of getting rid of the fraction. I'm going to multiply the entire thing by the common denominator. So the common denominator, or the least common multiple of the denominators, is 5. 5 and 1 both go into 5. And it goes 5 divided by 5 is 1 times 3 is 3x. 5 divided by 1 is 5 times 3 is 15. 5 divided by 5 is 1. 1 times 1 is x. And you don't have to write 1x. 1x and x is the same thing. I would just leave it as x. And then 5 divided by 1 is 5 times 1 is 5. And now I'm dealing with a problem that has no fractions. And I'm going to solve as I've learned before. I'm going to subtract x on both sides. I'm going to subtract 15 on both sides. And I'm left with 2x equals a negative 10. We divide both sides by 2. And my answer is x equals a negative 5. On this one on the left, the common mistake is people want to use a GCF. Remember, we're not using a GCF. We're using a... Alright, so as I was saying, we don't want to use the GCF. The common mistake there is people multiply through by 6. We've got to multiply through by 12. Because 6 and 12 both go into 12. 12 doesn't go into 6. You've got to multiply by that least common multiple. 12 divided by 6 is 2 times 5 is 10. And that's how you multiply by the fraction. 5, then multiply by the numerator. 12 divided by 12 is 1 times 7 is 7. 12 divided by 12 is 1 times 11 is 11. And then from there, it's pretty straightforward. 10x equals 4. When we divide by 10 on both sides, we get x equals 2/5. This one, if you can work with the fraction, sometimes it is easier than trying to multiply everything here through by 3. My advice here is I distribute the 2 into 1/3. 6 minus 2x equals, and in this case, 1/3 of 4. 4/3 x. 1/3 of 6 is 2, and then we add 5 to that. Now, if you still end up with a fraction here, okay, and that can happen, okay, my advice is this. If it eliminates all your fractions, you can go forward with it. If it doesn't, now I'm going to multiply everything by 3. When you try and get rid of a fraction that's going to be distributed, it can get confusing and get a little dicey. You're better off distributing first and then multiplying everything by 3 to get rid of that fraction. We get 18 minus 6x. 4/3 times 3 is just 4. 3 times 2 is 6, and 3 times 5 is 15. And now it becomes a basic Algebra 1 problem. 18 minus 6x equals 4x plus 21. I'm going to subtract, or I'm going to add 6x to both sides, and I'm going to subtract 21 on both sides. Once again, I'm a big fan of keeping that x positive. That's why I add x to both sides. When I do that, I have 10x over here, and I have a negative 3 on this side. We divide by 10, we divide by 10, and my answer is negative 3/10. So on these top two factoring problems, all I really can do, whenever you have two terms and they're not perfect squares, all you can usually do there is take a GCF out. The biggest number that comes out of 8 and 20 is 4. And the smallest exponent is x cubed, since there's an x in both terms. So I'm pulling a 4x cubed out of there, and I'm left with 2x squared minus 5. And I know I'm right if I FOILed it, or I distributed it back through. 4x cubed times 2x squared is 8x to the 5th. 4x cubed times negative 5 is negative 20x cubed. It's the same deal on the second one. 7 is the biggest number that goes into both terms, and x to the first is the biggest, or the smallest exponent that comes out. And now we're left with x cubed plus 5. And those are our answers. All right, when we're given a trinomial, okay, we want to factor it by, one, looking for a GCF. If there's no GCF, we're going to put our 2 parentheses down. And I'm going to key on the first term and last term. The factors of 3 are 1 and 3. The factors of 10 are 1 and 10 and 2 and 5. Since there's only one choice for 3, right away I can do 3x and x. The choices for 10 are 1 and 10 and 2 and 5. I always pick the middle ones, and I always make sure there's not a GCF. Okay? Now, if I do it this way to start, here's what I need to do. Is there any way to get 6x and 5x to equal negative 13? No. So if it doesn't work, what we need to do is we need to try something else. Before I go to the new numbers, I'm going to switch where the 2 and the 5 are. Now I have 3x times 5 is 15x, and 2 times x is 2x. Is there a way to make 15x and 2x negative 13? Absolutely. If I can make the 15 negative by putting a minus sign here, and the 2 positive by putting a plus sign here, that's my answer. 3x plus 2 times x minus 5. And that's a fact. It's literally it. Okay. These two special types right here, the 9x squared minus 24x plus 16, and 16x squared minus 9, we want to be aware of in this way. Okay? Whenever you have perfect squares on either end, a lot of times that's going to be a binomial square. So the first thing I'm going to check is the perfect squares of those numbers. 3x and 3x, which is the square root of 9. 4 and 4, which is the square root of 16. 3x times 3x is 9x squared. 4 times 4 is 16. Now, is there a way to get 12x and 12x to equal negative 24x? Sure there is. If I can make them both negative, negative 12 and negative 12 is negative 24. So there's your answer. Now, one more piece with this specific problem. Okay? Whenever you have the same thing written in the parentheses, and that's got to be numbers and signs, we're going to write that as 3x minus 4 squared. Okay, it's good habit to get into that. Down here, when you have two perfect squares with a minus sign, it means the middle term is 0. Once again, we're just going to take the square root of both terms. 4x and 4x, the square root of 49 is 7 and 7, and we have opposite signs. 4x times 7 is 28x, negative 7 times 4x is negative 28x, 28x and negative 28x cancels at 0, and that's our answer. That is a difference of two squares. Now I'm going to do the two on the right last. I do want to go through this one first, and then we'll go to the two on the right. Here, what are my choices for 5? This is a nice one. What are my choices for 5? 5x and x. I don't have any other choices. Multiples of 5 are 1 and 5. What are my choices for 3? 1 and 3. I'm going to put the 3 and 1 here to make it work the first time. Is there a way to make 5x and 3x 8x? Absolutely. 5x and 3x add up to 8x. So I would make both of these positive signs, and this is my answer. 5x plus 3 times x plus 1. So in this case, I can get a 3x out of here. 2x squared plus 13x plus 21. And you're bringing the GCF down, but you're just factoring what's left over. I'm going to do 2x and x, and now I've got to decide between 7 and 3. Or 1 and 21. You're usually going to use the middle terms, and if you look here, 2x times 3 is 6x, 7 times x is 7x, 7x and 6x can be combined to be 13x. So we have two positive signs, and this is the entire answer. You have to have the GCF with it. The GCF doesn't disappear. The GCF stays with your answer. Okay? Second one, I'm going to take a 4x squared out of there. The biggest number, the lowest exponent. I'm left with x squared minus 2x minus 15, which becomes a much simpler factoring problem. We're left with x squared, so x and x. My factors of 15 are 5 and 3, or 1 and 15. In this case, I'm going to say 5 and 3 will work. We get 3x, we get 5x, and I need a negative 2. If my 5x is negative, negative 5x and 3x becomes a negative 2. So the minus here and the plus here, and this right here is my answer.